how we could sketch a graph of the function f of x equals -3 times the log of x minus 2 plus 1. So first, let's think about the toolkit or the basic function that we're looking at here. So the simplest log function that we could consider that's part of this function is just our basic common log or our log base 10 function. If we think about a couple key features of this graph has a vertical asymptote at x equals 0 and a couple of key points that would be on this graph. If we think about f of 1, so the log of 1, log base 10 of 1 is equal to 0. So that's the point 1, 0. If we think about another point that would be easy to evaluate, if we think about f of 10, log base 10 of 10 is equal to 1. So the point 10, 1. So let's just sketch that, get a feel for what our kind of basic toolkit function looks like, and then we'll think about the transformations that have happened. So if we think about a vertical asymptote here at x equals 0, we have the points 1, 0, and 10, 1. So if you can picture kind of the shape of a log function, so it increases steeply along this vertical asymptote. It goes through our horizontal intercept at the point 1, 0, and then it starts to kind of level off as it heads off to the right there. So it's still increasing. It's increasing from left to right on its entire domain from 0 to infinity. So now let's look back at our function that we were given and think about what types of changes have happened. So this plus 1 that we have at the end added on as a constant means that we need to shift up 1 unit. Having this minus 2 on the inside of our function means that we need to shift right 2 units. And then having this -3 out in front tells us two things. The negative tells us that we need to reflect in the vertical direction. And because it's a 3, we also need to stretch by a factor of 3. So there's 4 different changes that need to happen. I'm going to do my one horizontal change first, and then when I look at my vertical changes, I'm going to take care of the reflecting and stretching first, and then the shifting from there. So now let's start thinking about where these points would be on our new graph. So I'm going to follow my points through these changes that have happened. So the first thing that I'm going to mark in is I'm going to mark in my new vertical asymptote. Since we are shifting to the right 2 units, instead of having a vertical asymptote at x equals 0, we're now going to have a vertical asymptote here at x equals 2 for our new function f of x. So now let's see if we can follow this point 1, 0 through these changes. So first, I'm going to take my point 1, 0 and I'm going to move it to the right 2 units. So we would be at the point 3, 0. When I think about my reflecting and my stretching, because it's right on the horizontal axis, that doesn't change this point at all. And so reflecting it leaves it in the same spot, multiplying by 3 keeps our output at 0, so we'd still be at that point 3, 0. But then I do still need to move up 1 unit. And so that original point on my toolkit function 1, 0 is now at the point 3, 1. Now let's follow this point that started at 10, 1. So first I'm going to move this to the right 2 units. Now I'm going to think about a reflection in the vertical direction. So since it was 1 unit above, when it reflects, it's now going to be 1 unit below instead. So I've done my shifting to the right 2. I've reflected it in the vertical direction. And now I want to think about multiplying that current y value by 3. So this is the vertical stretch by a factor of 3. So right now the y value is -1. -1 times 3 is going to be -3, so this is going to move further down to be at the point 12, negative 3. But there's still one more change that needs to happen. It needs to shift up 1 unit. And so from where we just stopped, we're actually going to go back up 1 unit. And so the final location of that point is going to be at 12, negative 2. So the reflection has made this curve look kind of upside down from what we had on our original graph. And so it's going to now start high along our vertical asymptote. It's going to come down through our point 3, 1, and then come over across to go through our new point at 12, negative 2. If we wanted to check these points that we came up with, so we came up with the points 3, 1, and 12, negative 2, we could evaluate our function at 3 and at 12 to make sure that it really checks out. So for example, if we evaluate at f of 3, we would have negative 3 times the log of 3 minus 2 plus 1. So this is negative 3 times the log of 1 plus 1. Well, log base 10 of 1, 10 to the 0 power is equal to 1, so a log finds that exponent. So negative 3 times 0, we have 0 plus 1 is 1. So 3, 1, that matches up with what we had found graphically. We could do the same thing for f of 12, negative 3 times the log of 12 minus 2 plus 1. We have the log of 10. So log base 10 of 10 is equal to 1. So negative 3 plus 1, we get negative 2, which matches up with what we found graphically as well. So we're using the same transformations that we used for other families of functions earlier in the course. We're just applying those ideas now to our new basic function. We can use our log base 10 function as our basic function and then apply the transformations.